It's another Mate here with teacher Jenny. Join me for another topic. This time we're going to talk about limits at infinity. Limits at infinity is where you have a limit problem wherein x there approaches positive or negative infinity. Let's have our first example. Limit of 3x to the power of 4 as your x approaches positive infinity. Now notice once you are going to consider x approaching to positive infinity, that means to say it's a big number to the right side or moving towards the right side. So once you are going to input a value here wherein you've got 3 and then x here will be representing a positive infinity, and once we are going to raise that to the power of 4, notice that our number will become bigger and bigger once we have a bigger power of that particular value. So that means to say that once we say positive infinity raised to the power of 4, that is still a positive infinity, a very huge number. And if we are going to multiply that to a 3, this will also become a bigger value, which is a positive infinity as well. So that is how you deal with your limits at infinity. The next example is the limit of negative 3x to the power of 5 as your x approaches negative infinity. So this one, we have the common multiple. So we are going to take out negative 3 here. And then we will be evaluating the limit of x to the power of 5 as your x approaches negative infinity. This is equal to negative 3 times our x here. We replace that with negative infinity. And then we raise that to the power of 5. So if you try to imagine a negative number, let's say negative 2 raised to the power of 5, since this is an odd number, it will also be giving off a negative result because we have there negative 2 times negative 2 times negative 2 times negative 2 times negative 2. This one will be a positive, while this one is a positive. Positive times positive, that's a positive, times our negative here, that's also a negative. So same concept will apply here. Once your negative infinity is raised to an odd number, then you will have there a negative infinity result. So this is negative 3 times negative infinity. So negative 3 times a negative infinity, a negative number multiplied to a negative number, that will give off a positive result. So this will be a positive infinity. We have the limit of 4x to the power of 4 as your x approaches negative infinity. So from here, we have a common multiple as well. So we take it out. And then we evaluate the limit of x to the power of 4 as your x approaches negative infinity. So from there, we can evaluate the limit of x to the power of 4 as your x approaches negative infinity. This is negative infinity raised to the power of 4. Notice the exponent is even. So once we have an even exponent and we're raising a negative number, the result will always be a positive number. So this will be now 4 times a positive infinity. And then 4 times a positive infinity multiplied by any number, which is positive, is a positive infinity. Let's go for a polynomial. So we have here limit of negative 2x to the power of 5 minus 8x to the power of 4 plus 7x cubed minus 10 as your x approaches negative infinity. So from here, we can simply break it apart. Like if you wanted to have a longer one, you can break it apart though, applying the limit laws, which is on the sum and difference. But the concept here is no matter how you are going to replace your x's here with negative infinity, it really doesn't bother the leading coefficient or the leading term here, because the leading term, which contains the highest exponent, there will always be giving off the bigger result. So, which means that once you have a polynomial, you always have to evaluate only the leading term. Leading term, the one that contains the highest exponent. So the highest exponent is 5 here. So we'll be focusing on getting the limit of negative 2x to the power of 5 as your x approaches to negative infinity. Because again, that this one will not be any more important. Now, when it comes to a limit at infinity, so we will be evaluating. So we have common multiples, so we take it out. This is negative 2 times our limit of x to the power of 5 as your x approaches negative infinity. So from here, we have negative 2 times evaluating our limit of x to the power of 5 as your x approaches negative infinity. We have that as negative infinity raised to the power of 5. So since the negative number here is raised to an odd number, then that means to say that that will still be a negative. So we have negative 2 times a negative infinity. That will be a positive infinity because we have negative times negative. That's a positive infinity. So that is how you get the limits at infinity when you've got a polynomial. So I hope you learned something. So please do watch out for the second part of this video in a while.